Hi, so for today, we're going to talk about solving systems of linear equation using the Cramer's rule. Okay? We're going to solve the three unknowns, x, y, and z, okay, using the Cramer's rule, which employs determinant operation in terms of matrix. So, for example, if we have a systems of linear equation in this form, okay, we have the equation 1, equation 2, and equation 3, wherein a sub 1, a sub 2, a sub 3 are the x coefficient or constant for each equation. B sub 1, B sub 2, B sub 3 is the coefficient of y or the constants for each equation. And C sub 1, C sub 2, C sub 3 multiplied by z. These are the z constant for each equation, coefficient of z's. And that is equivalent to d1, d2 over 3t, dt, okay, is equal to d sub 3. Those d sub 1, d sub 2, d sub 3 are simply the constants for each equation. So, if we have this form of linear equation, systems of linear equation, we can transform it, rewrite this into a simple matrix wherein we have here the coefficient of all the x of the equations, and we have the second column here, okay, of all the coefficients of y. Second, for the third column, we have the coefficients of all z's, and that is multiplied by x, y, and z, and that is equivalent to the matrix d1, d2, d3, which is our constant. Okay, and in order for us to find the values of x, y, and z, the unknowns, so we'll be having this formula. Note that this is not a really standard formula, but I've created this on my own. Okay, so we're in to get x, we have to get the determinant, okay, of the matrix AX. What is this matrix AX? Okay, matrix AX is actually we're going to replace this whole column of the values of the coefficient of x with the constant, okay, and get its determinant. Okay, and what is this determinant A? Okay, this is the matrix A. Okay, that is the matrix A. So if we're going to get the determinant, we'll be getting the value. So if we're going to get the determinant of matrix AX, upon which we are going to simply replace this first column with the constant and get its determinant, divided by the determinant of simply the A, we're going to get the x value. Same for y. For y, a sub y is we're going to replace this second column, all of the coefficients of y of all the equation, by the constant. For a sub z, we're going to replace this by this constant and get the determinant and so on and so forth and perform this operation. By this, we're going to get x, y, and z. So let's proceed now for our first example. So for this example, this is now already, we're going to put it into matrix form so that we have 1, negative 2, we have 3. So we have 1, 2, negative 1, we have 3, 2, negative 5, okay? That is multiplied by x to y, z, and that is equivalent to the constants here. So 1, 13, and 3. Okay? So we can label this as our matrix A. Okay? That is our matrix A. So if we're going to get the determinant of matrix A, that is a determinant of a 3 by 3 matrix. So we have 1, 1, 3, negative 2, 2, 2. Okay? So we have 3, negative 1, negative 5. Take note that we are going to copy the first two columns, okay, of this matrix in order for us to get the determinant. So what will happen? Okay, so if we're going to solve for the determinant, we have this diagonal multiplied, okay, and get their sum. So negative 5 times 2, negative 10 times 1, okay, negative 10 plus, we have negative 2 times negative 1 is 2 times 3, that is plus 6, plus 3 times 1 times 2, that is plus 6, minus the other diagonal, okay. So 3 times 2 is 6, times 3 is 18, so we have 18 here, plus, okay, 2 times negative 1 is negative 2 times 1, that is plus negative 2, okay. Again, plus Negative 5 times 1 is negative 5 times negative 2, that is plus 10. So we need to get the determinant of this matrix A because in our formula, matrix A is our denominator. So we're going to get that. So we have negative 10 plus 12 minus 18 minus 2 is 16 plus 10. We have 26 here. So we have negative 10 plus 12 is 2 minus 26. So we have a determinant that is negative 24. Okay, that is our determinant of A, negative 24. So in order for us to get the value of x, we have the determinant of a sub x over the determinant of a. So this a sub x, okay, is a matrix that we're going to replace all the values of the x here, okay, coefficient of x here by our constants. Okay, again, we're going to replace this, okay, coefficients of x with the values of the constant. So we have 1, okay, we have 1, 13, and 3, and copy the remaining, okay, elements in the matrix. So negative 2, 2. So negative 2, 2, 2. And then we have 3, negative 1, negative 5. So 3, negative 1, negative 5. And of course, we're going to get the determinant of this. So if we get the determinant, again, the same procedure. We're going to copy the first two columns, 1, 13, and 3, negative 2, 2, and 2. Okay? So going to get the determinant, we have 1 times 2 times negative 5. Okay? That is what? Negative 10 plus negative 2 times negative 1 is 2 times 3, that is plus 6, plus we have 3 times 13. Okay, 3 times 13 is, let's say, 39 times 2. Okay, that is 58. Okay, 39 times 2, that is 58. Oops, no, 13, 3 times 13 is 39 times 2, that is equivalent to 78, not 58, sorry. So 78, and then minus the other diagonal, 3 times 2 is 6 times 3 is 18, plus 2 times negative 1 is negative 2 times 1 is still negative 2, and we have negative 5 times negative 2 is 10, plus times 13 plus 130 here. Okay? So if we're going to evaluate this, okay, I hope you can follow because you're already done with matrices or determinants. So we have negative 10 plus 6, that is negative 4, plus 78, that is 74, minus 18 minus 2 is 16, plus 130, that is 146. So 74 minus 146, okay, is negative 72, if I'm not mistaken. Okay, so let's say 146 minus 74, we have 2, okay, and borrow 1, we have 72. So negative, since negative number is larger, we have a negative 72 here. So negative 72. So our value for x now would be the determinant of ax, which is negative 72, over the determinant of a, which is negative 24. So, okay, negative 72 divided by negative 24, okay, 72 is divisible by 24, and that is negative divided by negative, that would give to a positive value, and that is 3. Okay? So we now solve, or we now have the value for x. How about for a sub y? Okay? So for y, we have the formula y is equals to determinant of a sub y over determinant of a. Determinant of a, we have already the value. Okay? So what are we going to do with the determinant of a sub y? Okay? We're going again to have the matrix. Of course, we're going to replace the second column, okay, the coefficients of y by the constants. So we have copy this and this, but replacing the second column with the constants. So we have We have 113, and we have 113, 113 and 3. 113 and 3. We have 3, negative 1, and 5. Of course, if we're going to get the determinant, copy the first two columns. So 1, 13, 3, and get the determinant. Okay? So if we are going to get for the determinant of this should be 13 times 5. Okay? 13 times negative 5. I'm sorry, this is negative 5. Okay, because this is a negative. So from our given, that is a negative 5. Okay, let me just check. 3, negative 1, and negative 5. So 13 times negative 5 is negative 65. Okay, plus, okay, plus 1 times negative 1 is negative 1 times 3, that is negative 3. Plus 3 times 1 is 3 times 3 is 9, minus the other diagonal. 3 times 13 is 39. 39, okay. 39 plus 3, okay. 39 plus 3 is, or 39 times 3. 39 times 3 is, because we have 3 times 13, 39 times 3 is 117. So let's try. 39 times 3, 27, 2, di ba? We have 3 times 3, 9, 117. Okay? So 117 here plus 3 times negative 1 is negative 3 times 1 is still negative 3 plus, okay, negative 5 times 1 is still negative 5. So we have here negative 65 minus 3 plus 9 minus 117 minus 3 minus 5. Okay? So because of negative 5. So minus 5. And we have negative 65 minus 3 is negative 68. Plus 9, that is negative 59. Okay, minus 117 minus 8. Because negative 3 minus 5 is negative 8. So we have negative 59 minus 117 minus 8, that is 109. So if we're going to calculate that, negative 59 minus 109, okay, so that should be what? Our AY, determinant of AY is negative 168. Okay? This would simply add but with the negative sign. So therefore, our value for Y is the determinant of AY over the determinant of A. So we have negative 1 of 168 over the determinant of A, okay? Of A, which is again negative 24. So negative 24. So what will happen here? Still, negative 168 is divisible by negative 24. So 4, 8, 12, 16, 20, 24. So this should be, I think, okay, if we divide this, that is equal to 7. Okay? Okay, that is equal to 7. And lastly, for us to find Z, okay, we can either perform substitution on any of the equation because we already know the values of X and Y. But for the sake of our discussion, we'll be sticking with our formula. Okay, let's try to get Z by this formula. Of course, we will be having the determinant of our matrix AZ. So our AZ is what? We're going to replace the third column or the coefficients of Z with the constant. So we have now the formula or the matrix. We have now the matrix 113. Okay, 113. Then we have negative 2 and 2. Okay, negative 2, 2. Negative 2, 2. So I have negative 2, 2, 2. And then we have now the values or the constants of the constant which are 1, 13, and 3. So 1, 13, and 3. So copy the first two columns and get the determinant of this 1, 1, 3, negative 2, 2, and 2. So we have now, okay, get the determinant. So we have 1 times 2 times 3, that is 6. Negative 2 times 13, negative 26. Negative 26 times 3, negative 26 times 3. So 26 times 3, we have 18, 6, 78. So that is negative. Okay, plus negative 78. Because negative, we have negative 2 here. Okay, 1 times 2, that is simply plus 2 minus the other diagonal here, 3 times 2 is 6. Okay. Plus 2 times 13, 26 times 1 is plus 26. So we have 3 times 1 is 3 times negative 2. 3 times negative 2 is plus negative 6. So we have, okay, 8. 6 plus 2 is 8. Minus 78 minus, we have 6 plus 26 minus 6. So we have 6 minus 6 here. So we have 8 minus 78 on the left side. So we have 8 minus 78 is negative 70 minus, this should cancel, 6 minus 6 minus 26. So we have negative 70 minus 26. That is negative 96. Okay? And the value for our z, to get our z, is the determinant of a sub z over the determinant of a. Determinant of a sub z is negative 96 over the determinant of a is negative 24. Okay? And if we divide this, negative 96 is divisible by negative 24, we shall get an answer of 4. So, the values for our x, y, and z are 3 for x, for our y is 7, and for our z, that is equivalent to 4. And that's all for today's lesson about Cramer's rule. Okay, so it's very easy to find the values of x, y, and z if we already know how to perform determinants and of course to use these formulas. So thank you so much for listening. This is Engineer Abat. Thank you so much. Please don't forget to subscribe to my channel. So I hope you learned something. Thank you.